Okay, today we're going to review actually 4 different methods for 2-digit addition when you're making a new group. And the different methods that we're going to be working with today are new groups above, new groups below, show all totals method, and then I'm also going to demonstrate how to make a proof drawing. At the end, I'll take out the base 10 blocks to show you exactly how this all connects so that you can work with your children at home, or second graders, you can practice. And you'll have an opportunity to see all of the different methods together. Because, as you know, there's more than one way to solve a problem. So it does not matter which way you use, as long as you find a method that's successful that you can use quickly. So the first method that we're going to practice is new groups above. And I chose this one because this is the way that I learned when I was a second grader, and most of your parents have learned as well. So with new groups above, we always start with the ones place. And notice we made sure that we lined up our ones place. If I take a piece of paper and put it over, all of my digits in the ones place are lined up. All of my digits in the tens place are lined up. And that is important so that we don't make mistakes. So we're going to start by adding the digits in the ones place. And I'm going to think to myself, 4 ones plus 8 ones are 12 ones. 12 ones, ooh, I made a new 10. So because 12 is 10 plus 2. So 2 ones plus 1 new 10. And notice again, I wrote my new 10 right at the top. And if you look, if you can imagine in your mind 1 10 and the 2 making the number 12. Now I'm going to add my tens place. 1 10 plus 6 tens plus 4 tens are 11 tens. I can also quickly think to myself, I know that 6 and 4 are partners of 10, plus 1 more is 11. If I have 10 tens, I've made a new 100. Now I have 11 tens. So that means I have 1 10 and 100. Notice now I wrote my new 100 in the hundreds column. Even though there's nothing here, I still have to show that I have it by marking it up there. And this is in my hundreds place. Then I'm going to bring that one down. My answer, 112. This is the new groups above method. Now, new groups below method was a method that was created because oftentimes children were forgetting to write the new group above, and then they were only adding like 6 plus 4, which caused them to make an error. So mathematicians worked together and they realized that some people can put the new group below, and we'll look at that now. So new groups below, we also start with the ones place first. So we're going to think 4 ones plus 8 ones is 12 ones. Except this time we're going to put our 2 here, and our new 10 goes right here. And let me show you, now you might be able to understand why some mathematicians decided to put the new group here, because now you can easily see, do you see the 1 and the 2 making a 12? That was easier for some children to picture. So we have 110 that we created. Now we know that, again, that 6 and 4 are partners of 10, so they make 10. And 1 more 10, so we have 10 tens plus 1 more 10 is 11 tens, which means I have 1 10 and now 1 new 100. But of course, we're not finished there. We have to write in that new 100. And again, if you look, if I cover this up with a paper, if you're at home, you can use a Post-it or a sticky or just any piece of paper to help make sure that you're lining up your place values. So again, we have our ones place, our tens place, and our hundreds place. Now we're going to look at the all totals method. And I think that this method is another way of really breaking up the numbers, and it ties in with using expanded form. So if you are good at expanded form and really understanding numbers and their values, you'll be very good at this. So with the all totals method, we actually start now with the largest value place. So instead of starting with our ones, we're starting with our tens. So with the all totals method, we're thinking not 6 plus 4, but 60 plus 40. Because 6 tens is 60, 4 tens is 40. 60 plus 40 is 100. And notice again, I line up my place value. My digits are lined up by place value. After I add my tens, now I'm going to add my ones. 4 plus 8 is 12, which is why it's so important to make sure we know our math facts. Now I'm going to add my ones, my tens, my hundreds. 112. Notice we come up with the same answer. They're all correct. There's not just one way to do this, and you might have other ways to do math and solve math problems that are correct. It's just a different way of thinking and trying to get you to be able to think in lots of different ways so that you know that there's more than one way to solve a problem, and then the choice that you make is to choose the best solution or the best method for you in order to get to the solution of your problem. Now we're going to look at proof drawing. So when we're working on math problems, you should be choosing new groups above, new groups below, or show all totals method. Your proof drawing is like your check. It's one way you can check or prove that you are correct. But we do not, it would take us a long time, wouldn't it, boys and girls, to solve every math problem using proof drawing, especially when we get to 3-digit addition. So we want to try to make sure that we're just using this as a check. So now I'm going to make my proof drawing, 64. I start by making 10 sticks in sets of 5. So 10, 20, 30, 40, 50, 60, 1, 2, 3, 4. And then 48. 10, 20, 30, 40. 1, 2, 3, 4, 5, 6, 7, 8. Notice that even over here, I tried to keep all my ones together and all my tens together. And that's really important because it helps make sure that you're really understanding place value, that each digit has its place. Also notice that I did sets of 5 because we're experts at counting by 5s, and it makes it go faster. It makes it easier for your brain to look at it and quickly get it. So now I'm going to use a different color marker. And first I'm going to look at my ones, and I'm going to ask myself, did I make a new 10? So I've got 4 plus 5 is 9, plus 1 more. I sure did. So I'm going to put a loop here around this, and I'm going to draw my new 10. And I could put my new 10 here, or I could put it up here. That doesn't really matter. What matters is knowing that I put all of these together to make a new 10. Now I want to look to see, did I make a new 100? Oh, this does matter. Sorry. This is 40. Since I have 10, 20, 30, 40, I should put that new 10 here to make a set of 5. My apologies. So now, our second graders are so smart that they know that 50 plus 50 is 100. So we're going to put a rectangle or box that, because we know that this is 100. This represents 10, this 1 10 stick. And then these two that we have left over are our two ones. 100, 10, and 2 together are 112. There's our proof drawing. And now to further prove and demonstrate this, we'll get out the actual base 10 blocks. And you can kind of look here at my actual base 10 blocks and you can see how our 10s are representative of that. So if I had 50, 60, 64, and I'm going to just zoom down a little bit so that you can see, plus 48, 10, 20, 30, 40, 1, 2, 3, 4, 5, 6, 7, 8. So here I have 64, and here I have 48. Now I'm going to look at my ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I put all of these together, I just made a 10. Do you see here how we loop them all together? So I'm actually going to trade them out. I'm going to take them off of my board and replace it with a 10 stick. And I'm going to add that 10 here to the 40 so that I have 50. Now I can see here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Which is what I did here. I put a box because I'm showing that I have 100. So now I'm left with 100, 10, 11, 12. 112. So let's just give you a minute to look at how all of the strategies are connected. And hopefully that will help make the understanding of this concept a little bit more clear for your second grader. So second graders, a reminder to you, if you're doing this, you're going to look which of these three methods are you most successful with that you would want to use to solve all your problems. And then when you're done solving it, can you prove that you're correct or do a check using a proof drawing?